How you going, guys? Kurtis from Cutting Edge Engineering. Today we're going to be test fitting our engine into our Franna crane, and we did decide to upgrade it, so we're going to show you what we got. So as you can see, this is not the original Perkins engine. This is a Cummins 6BT, which means it is a 6-cylinder turbocharged 5.9 litre, and it is rated for 400 horsepower. Comparing this to the original Perkins, which was a 4-cylinder turbocharged engine, which had a maximum output of 110 horsepower. So if you remember, the original engine was not in very good shape at all. It did need an entire rebuild from top to bottom. We did go through the process of getting all of those parts quoted up from a few different suppliers here in Australia and abroad. And when we added that up along with the specialty machining we would need for the cylinder head and the block, that was far too much money we were willing to spend on that engine. It would have actually been cheaper to get a replacement, but the only one we could find was a constant speed engine, and it was over $20,000, and in order to use it for our application, we would have had to put a $5,000 fuel pump on it so we could use it in the crane. So that's when we started looking for an alternative. We did look at the Nissan, the Isuzu, and a lot of the European models that were out there, but something that I decided early on, I didn't want something that needed to be powered by an ECU or an ECM, which drastically narrowed down our choices. And it was at that point I decided we were going to go with a Cummins 6BT because the engines are available pretty much all around the world, and there are a lot of part suppliers here in Australia, and there is a lot of information about them online. Not only are they reliable and bulletproof, but with a straight pipe, they sound awesome. So obviously we're not going to be using this to its maximum output of 400 horsepower, but we did have quite a few options, and this was the most cost effective and my favorite choice. And how we managed to get our hands on this one was actually through Facebook Marketplace. A guy just up the road from me had imported it into the country to put it into his Land Cruiser, and he did actually do some upgrades. He did spec up the fuel pump and put a slightly bigger turbo on it. He then decided he wasn't going to do that conversion, so he sold on the engine, and we purchased it for a lot less than we could buy anything else. So this engine is basically plug and play and ready to go, but in order to get this to marry up to our transmission, we did have to get a new bell housing, but we did manage to find one second hand through a local diesel parts supplier, and all I had to do was give that a sandblast and a paint job, and it came up like brand new. So what we're going to do is get the bell housing bolted on so we can then fit our transmission. So that fits spot on. I'm not going to be fitting the flywheel today because we are just test fitting everything, and we are going to have to pull it all apart again. So now we can fit the transmission. And the transmission has had a full rebuild by a local industrial gearbox repairer. They completely stripped it down, inspected all of the parts. They then went through and replaced all the gaskets, the O-rings and the bearings. They also replaced all of the friction plates, fitted a new torque converter, reassembled everything, and then tested it. So this is as good as new. Before I fit this, I am going to remove the torque converter just to get it out of the way. And the last thing we're going to bolt on is the air compressor. Now we've got everything bolted on, we're going to get it rigged up and off the pallet. To test fit this, I am going to be using our overhead crane. That is the safest and the easiest option. With the overhead crane, I do have a lot of control with that, and I can place things exactly where I want them and make very small adjustments. Now I've got that balanced the way I want it, I'm going to unbolt the engine from the pallet.
What's in the boxes?
So here on the pallet we also have a few parts that the guy who ordered this engine got with it. One of those is an electric vacuum pump. Because diesels don't make a vacuum, you need to have one for the brake boosters to work correctly. We're not going to need that, so we're just going to put that on the shelf. And we also got a set of brand new 14mm injectors, so if we want to pull massive horsepower out of it, we can change out the injectors to these, screw a bit more boost into it, and get a bit more power. And there's also a spare belt for the accessories on the front of the engine. And for those of you wondering about the old engine, we did end up selling that on Facebook Marketplace to a farmer that's out west. He does use that particular engine in a few of his farm machines, so it didn't go to waste and he was able to use a few of those parts. So we are ready to test fit this into the rear frame. Unfortunately, the overhead crane doesn't reach the front of the workshop, which means we're going to have to bring the rear frame to this area so we can do it. But hopefully that's not going to be a problem for too much longer. I am actually getting pricing and quotes to have an overhead crane put in the entire workshop, which will make doing things like this and all of our other jobs a hell of a lot easier. So we're just going to get this moved back so we can bring in the rear frame.
Let it sit there.
Righto guys, so that is our engine in the crane. Our transmission mounts have lined up perfectly, but unfortunately the motor is not sitting in the exact right position. On this side we've got about 10 mil of clearance between the air compressor and the chassis. I did know that was going to be a little bit tight. On the other side we've got a lot more room, about 50 mil between the chassis and the alternator and the aircon compressor. But what's actually held us up is the bolt that holds on the belt tensioner. So the engine is actually not sitting at the correct height at the moment. It does need to come down about another 20 mil, but the original saddle is stopping it. So what that means is what I was hoping to avoid, and that is to gouge out the saddle and then move it about 100 mil to the back of the crane. But that's not such a big problem because I'm hoping I can incorporate the hydraulic pump mount into the saddle, and by doing that, that will hopefully eliminate all of the other bracketry that was attached to the original engine to hold onto that pump. But something we do need to do, which is the reason why we test fitted the engine, I need to get Troy out here to draw up the new engine mounts because the original ones on the inside of the chassis are not going to be suitable and we'll have to gouge them out and replace them. So what we need to do now is make sure the engine is perfectly centered in the chassis. Then what I can do is get Troy out here to take some measurements so he can draw up the new engine mounts and get those parts cut. And once that's done, I can remove the engine and get the frame back outside so we can gouge off all the parts we're not going to need.
Is there even any difference?
No, it's actually sitting perfect.
Oh.
So that's actually sitting perfectly parallel with the chassis, which means we don't have to do any centering.
That should be about right. Oops. It's going to be pretty close, I think. $251. I like that.
So Troy has just taken some measurements of the original mounts because we will be replicating them. He has taken as many measurements as he can, but he still needs to measure the overall width of the block where the engine mounts bolt onto. But we can't get that while the motor is in the frame because we already know the inside of the engine bay. Once we get the outside of the block, we'll be able to 3D design and draw those engine mounts and know that everything's going to fit perfectly. Drop it, drop it. Good boy, sit. Drop it. Sit. Sit. Stay. Plug this in. There we go.
You're gonna fall off. Hold on.
Take it, take it.
Drop it. Sit. Stay. So to remove all the parts we're not going to need, we are going to be using carbon arc gouging, also known as air arc. It is a thermal cutting process where you use a power source and a carbon rod along with compressed air. In our case, we're using a DC 400 Lincoln power source that then feeds power into the arc air handpiece along with compressed air. And the compressed air comes out of the clamp that holds onto the carbon arc rod. And we mainly use two different types of carbon rods. We have a round rod which is 10 mm in diameter. We use that for cutting and removing weld. We then use a flat rod which is used for wiping away weld material and making everything nice and flat. And the way it works is the intense arc created from the carbon rod onto the metal workpiece makes that material molten, and then the air jet blowing down the side of the rod blows that molten material away. So there are other ways you can remove parts, such as plasma gouging or using an oxy and acetylene gouger, but this is by far my preferred method for removing metal very quickly. And that's because I've got over 20 years experience using the air arc gouging method. The cost to set up was only about $2,000, and the consumables are very cheap as well. For a box of 50 carbon rods is only $20. And when you know what you're doing, you can be extremely precise. You're able to remove weld joints that you can't actually reach with anything else. So that's the engine mounts and the saddle gouged out. But while I'm doing this, I'm also going to gouge out the articulation plate that has all the rust pitting in it. Now that all of our parts are gouged off, we're going to go through and grind down all the welds. Righto guys, so now all that work's done, we can continue on with the fabrication of our rear frame, but we just need to wait for all those parts that we've ordered, and you'll just have to stay tuned for that video. Thanks for watching.
Is that the turbo?
That's the turbo. How big is it?
It's so cute. There's no room to put a bigger one on there, is it?
Oh, unless we got a high mount. And I could always cut the mounts out of the body and put a Cummins 6B or something in it. And for those of you wondering, to tet fit.
Tet fit.
Test fit. To tet. So we are ready to test this.
Oh my god.
So we can gouge off all the. And once that. So that's when we started looking at alternative options. And the transmission has had a full rebuild by a local. Oh, fucking me.
Fucking me.
Fucking me. Fucking me, fucking you. I'm just getting fucking nailed everywhere.
Can you lay on top and gouge down?
Oh, wait.
Was that a new filter?
Brand new.
Lay down.